Okay, so today there are tremendous challenges in spreading fertiliser. Farmers and tillage farmers want to spread at wider and wider bout widths, and they're also using fertiliser of variable quality. The physical quality of fertiliser can differ. So this creates greater challenges for the actual fertiliser spreader. So it's hugely important that farmers select the right type of fertiliser spreader and that they set it properly to spread the fertiliser evenly. In selecting the spreader, you have to take into account the bout width that you're going to spread to, the width, whether it's a 12 metre or 24 or 30 metre tram line, and the quality of fertiliser that you're going to use. Those are the key things. And what we're looking at really are the performance test results of the spreader itself. We want ideally a triangular spread pattern which will overlap with the adjacent pattern very well, and you want a low coefficient of variation of the overlap pattern. So those are key things that the farmer should look at when selecting the spreader. All of the other items in the spreader selection are important as well, such as headland spreading mechanisms, and now items like section control and GPS positioning related turning on and off are hugely important as well. But the main thing still is a spreader that will spread evenly. Once you have a spreader that spreads evenly, you then must make sure that it will do that on your farm with the particular fertiliser and the bout that you're working with. And to do that, you need to use the manufacturer's resources in terms of setting the spreader. So different bout widths, different quality fertilisers require this fertiliser spreader to be set up in different ways. And when we say being set up, we're talking about it differs from fertiliser spreader to spreader, but it may be the position of the vanes, the type of vanes, the speed of the spreading disc, it may be the drop point onto the vanes, it may be the angle of the spreader. And the only way we know how to set those is to use the manufacturer's resources. And these increasingly are online resources, or indeed phone app type resources, where the manufacturer has a huge database of test results, and we try and match our situation with our own fertiliser to one of those spread patterns in the database. So that's a hugely important task for farmers to do. So those really are the main two things: to select the right spreader and to set it evenly. The third and final part really is fertiliser quality. Okay, so what you're looking for is fertiliser that will spread well, and a dense product, maybe round shaped particles but large particle size, will tend to spread very, very well. So we need to buy our fertiliser with that in mind, that it has good physical quality for spreading. Okay. A particular challenge though today is urea, because urea is being used more on farms. It's a less dense product, so it is harder to throw. So we need to make sure that the spreader is capable of doing that. And again, you're going back to the manufacturer, or preferably independent test results, to show that we can spread urea to those distances. But even if they can show that you do that, you need to be very careful with urea at wider bout widths, in excess of 24 metres, and in windy conditions. And the biggest challenge of all maybe is spreading blends of fertiliser with urea blended with other fertiliser of different physical quality. That's a really big challenge, and I would advise most farmers not to consider using blends unless the supplier of the blend can show you test results that shows that it will spread to the required bout with your particular spreader. So those are the key points: correct selection of the spreader, correct setting of the spreader, and good fertiliser quality. And those are the key points that we're discussing on this stand. The actual spread pattern that we get when we spread the fertiliser is hugely important. On the top graph here you can see quite a good spread pattern. It's basically triangular in shape, and the red line at the top shows a pretty even line across the full width, so when it's overlapped, that's what it will look like. On the other hand, if we look at the bottom graph here, this is what we'd call a shoulder pattern. It's not really triangular, it has two shoulders at each side. This is not a good pattern for matching, if you like. So when we match this with the next run of that spreader, the overlap line, which is the red line, is moving and waving up and down a lot. So it has a much higher coefficient of variation. Ideally, the top pattern is better and easier to work with, and it's probably a more robust pattern, so that in certain conditions, in windier conditions or with varying quality fertiliser, it will cope with that a bit better, whereas the shoulder pattern requires very, very careful setting of the spreader. So the physical quality of the fertiliser is hugely important, and we need to actually determine what that quality is. So some of the key things we can do is we can look at pictures which describe the particular type of fertiliser, whether it's granular or whether it's prilled or whether it's a blend of something like that. But more importantly, we can actually get the size distribution by using a simple sieve box test, which we see here. In other words, this is a little box, you shake the fertiliser in it, and it gives us what proportion is in particular size categories. With that information, we can then set the fertiliser spreader properly. In terms of the design of the spreader, the spreading elements are hugely important, particularly the vanes here, the yellow part on this particular spreader. There's a huge amount of design in this here to make sure that it throws the fertiliser exactly where we want it. In this particular spreader, this turn in an anti-clock, a different direction than in most spreaders, but the vane design is hugely important. Vane wear is also important. For instance, if you look at this particular vane here from a different spreader, we can see here that it has actually worn through at this point, patterned here, and that's wear from the fertiliser. And with this sort of wear, it is going to affect the throw of fertiliser as it's been spread. So again, wear like this will have a hugely detrimental impact on spreading evenness. So the design of the vanes, and indeed keeping them, maintaining them, replacing them when they're needed, is hugely important. On some spreaders, it's actually the fertiliser drop point. Where the fertiliser drops on the disc is important in terms of determining, in terms of setting for the correct width and the correct fertiliser. On this machine here, you can see towards the base of the disc, and you can see a scale on the outside here. That's adjusting the drop point of the fertiliser onto the disc, and it'll affect its spreading characteristics in that way.